All right, so welcome. We are on section 11.4, guys. So 11.4 here. Hopefully you guys are doing well so far. Like I said, if you guys are not doing well, please at this point, hopefully you understand it. Shoot me an email, shoot me a message to remind. If it's between the hours of 8 to 3, I will respond within the hour, most likely. Unless like it's a Zoom session and I'm working with other people, but otherwise, like, I'll get back to you right away. So please, guys, if you have any questions, and you're struggling, don't feel like there isn't resources out there. I'm here to help you, and I will do whatever I can to help you guys out and make sure you're successful and are passing and getting good grades. So please let me know with that. But this section is going to be 11.4. Okay, so 11.4. This is going to be area of regular polygons. And so just going back to what a regular polygon is, a regular polygon is just where all sides and all angles are the same. Okay, so a polygon is basically just a closed figure. So we're saying like any shape that has all side that is closed and has all sides and all angles congruent. So if you look at our example over here, all right, so that's where we have a hexagon. We have a hexagon, okay? So what we're going to say is the distance from the center of a polygon to any side, all right, is called the apothem. And it's a word that we haven't talked too much about, but it's really not. If you hear that, that's my dog in the background. Sorry, he goes crazy every once in a while. But the apothem is just this length right here, okay? So it's the distance from the center of a polygon to any side, okay? So that's going to be our A. And then what we call, and this is a little bit different, that's why we have the circle there, because if you look, if we go from the center, I'll switch colors here so we understand what we're talking about. If we go from the center to the outside, and we had a circle there, not the hexagon, a circle, you guys would be like, oh yeah, that's a radius. So that's what, the name doesn't change. So we're trying to keep things as simple as we can. So that's still called a radius. So the radius of a regular polygon is the distance from the center to the vertex, okay? So that is that's our radius, okay? Now, the formula we're going to use is right here, okay? And it's just 1/2 the apothem times the perimeter. So a couple things we have to figure out, all right? So let's just get through some examples here. So we're going to have to find the area of each Rigueur polygon. 1 and 2, pretty simple. They give you the information you need. You don't have to do any calculation, okay? So they tell you that, hey, the apothem is 7, and the perimeter, all we have to do is we just have to add up 24.2 plus 24.2 plus 24.2, or 24.2 times 3, since there's 3 sides, and the perimeter is going to be 72.6, okay? From there, we just plug it in our formula. So the area is going to be 1/2 of 7 times 72.6. All right, so that gives us a total area of 254.1 feet squared. It is squared because we're talking about area, so just a different way to calculate area for these specific figures. Number 2, we have the apothem. It equals 16. And our perimeter, well, one side is 13.3, so we just have to add up 13.38 times, or do 13.3 times 8, and that's going to give us 106.4. And so then we plug in everything to our area formula and take 1/2 of 16 times 106.4. Now I'm just following the formula there. I'm just following the formula, guys. Just taking 1/2 the apothem times the perimeter. So that's the formula. That's the formula we're going to use for the whole section here. So that gives us an answer of 851.2 centimeters squared. Now we're going to cut off here in a second with this notes video, but I do want to scroll down here. Hopefully you guys don't have any questions on 1 and 2, just very straightforward. But what we're going to have to use, trig or special right triangles, okay? Trig or special right triangles, because sometimes if you look